So we're talking about TLSv1.3. I titled this minor version and major changes. Because I think going from 1.2 to 1.3 wouldn't be that big of a deal, but that'd be a little deceptive. So we'll talk a little bit about an overview, kind of history as we go in. So if you were at my talk yesterday about the basics of cryptography on basis of SSL, a couple of these facts will be redundant, but not everybody was there. Quick history. SSL started off back in the 90s under Netscape. SSL1 was actually never released to the public. If you actually had something running SSL1, you must have had like a beta Netscape product. SSL2 was the first real public release that was adopted. That was way back in 1995. SSLv3 very rapidly came out in 1996 because SSLv2 had some, let's say, fundamental flaws. And there's a lot of feedback on SSL after it was released, and so very quickly that was patched up and SSLv3 came out. And that was kind of the basis for a while. SSLv3 got widespread. Other people other than Netscape started supporting SSL, Microsoft and IE, because back then that was basically the other browser. It started getting adopted, and people kind of realized, Netscape included, that if this is going to be a building block for the internet going forward, having a single corporate entity control the standard probably wasn't going to fly. And so it was moved over to the IETF as an RFC, as in most internet standards come from. And that would happen in 1999, and TLS 1.0 was published. TLS 1.0 was basically not a big change from SSLv3. It was kind of a codification of what SSLv3 had, along with some errata that had been published in those intervening years. Just kind of setting a baseline. This is where we are. This is a standard everyone can agree to. So work began pretty much immediately on improving it, but it took 7 years to get TLS 1.1 out. And then we went to TLS 1.2. It was really the goal that came out in 2008, and it's been 10 years since our last major rev of TLS. We've been on 1.2 since 2008. TLS 1.3 was published on Friday, last week, less than a week ago. We have initial support for TLS 1.3 in 14.0, which came out last week as well. It's not final support, it's for draft 26. As I'll talk about a little bit, the final version is actually draft 28 became the RFC. It was just a timing issue. When code had to be frozen for the release, the standard was still being revised, and we happened to freeze as draft 26 was the then current draft. So we'll see in the future version, the next version to come, we'll have final support. So it's TLS 1.3, but as I kind of alluded to in the title of the presentation, it's kind of more like TLS 4.0, which is actually really what I wish they'd called it. The changes going from 1.0 to 1.1 to 1.2 are all fairly minor. If you look at it, it's adding new cipher suites is to the standard, adding security renegotiation things, and they're basically making tweaks based on feedback and evolving attacks and things. But 1.3 is a radical overhaul to TLS. There was actually debate during the development of what became 1.3 of what to call it. A lot of people wanted to call it 2.0 because it was a new major revision. And there was also a strong argument to call it 4.0 because we have SSL 2 and 3, and there was still confusion out there, the fact that TLS 1. something is greater than SSL 3. something. So there was an argument like, well, if we just make it 4, it's not only is it a new major rev for TLS, but it's greater than 3, and all that confusion goes away. And I thought that's a great argument, and it lost. So it's still TLS 1.3. And internally, to make it even more confusion, for those who do TLS debugging on Wireshark, you know that the TLS version numbers are still incremented off the old SSL version number. So internally, TLS 1.3 is version 3.4. It just really confuses the hell out of everybody. And another reason why I think calling it 4.0 would have made sense, because then you could have made the internal version number 4.0 as well, and it would have been greater than 3, and everything would have worked. But no, we lost our opportunity. So right now, as I said, TLS1.3 is in 14.0. It's draft 26. The full support for what is now RFC 8446 will be in a future release, and I'll say it verbally, it's probably 14.1. We'll have the full version. Oh yeah, and it's TLS1.3 is RFC 8446. It was published last Friday, and there's, you can, any RFC publication site, like the IETF site, that was what was formerly draft 28. So what's new in 1.3? Well, a lot. A lot of it is actually stripping the protocol down. A lot of things have been removed from TLS 1.3 because things have evolved. The compression has been an attack vector for TLS. That's gone. There's no compression included in TLS anymore. Renegotiation is gone. Negotiating elliptic curve point formats in the handshake is gone. The change cipher spec message is completely gone, kinda. I'll talk about that. All kinds of cipher suites have been removed. Things that have become deprecated or vulnerable to types of attacks or families of attacks over the past several years under TLS 1.2 and earlier are just basically, I said, fine, this is our opportunity, they ripped them out. So all static RSA key negotiation is gone. Non-ephemeral Diffie-Hellman, elliptic curve Diffie-Hellman or just straight up Diffie-Hellman is gone. RC4, DSA, MD5, SHA-224, export ciphers, those old ancient 40, 56-bit ciphers, any of the weak elliptic curves that have been determined to be weak in the past few years, a whole bunch more stuff is just gone. The protocol is very stripped down, or what's supported in it. All the cipher suites that were defined for TLS 1.2 and earlier are gone. Nothing that worked in TLS 1.2 works in 1.3. There are replacements, but any cipher suite, the definitions for them are completely new in TLS 1.3. All key exchanges in TLS 1.3 must now be either ephemeral, so either elliptic curve Diffie-Hellman ephemeral or just straight up Diffie-Hellman ephemeral, which means perfect forward secrecy, or they have to be a pre-shared key system where you've got like, maybe you wouldn't see that very much on big IP, but maybe you have like a dedicated site-to-site VPN where you manually configure the keys on either end, so you have a pre-shared key situation. And all the supported ciphers are now what they call AEAD, or authenticated encryption with associated data, such as AES GCM. So any old cipher block chaining mode ciphers are gone. So there's a lot of changes to the protocol, which has lots of knock-on effects, as we'll see. It also introduces a lot of new stuff that wasn't in TLS 1.3. It doesn't just remove things. So the handshake now can be done, the standard handshake is what's called a 1 RTT, or 1 round trip time handshake, which speed things up over TLS 1.2. And we'll look at some handshakes as we go. There's also support in TLS 1.3 from the standard for 0 RTT, which basically means you can start sending data in the first packet without waiting for the handshake to finish. I'll talk about that a bit. We don't support that yet. It's on the roadmap. Elliptic curves, which were added on as addendum and additional RFC to RFC 1.2, they weren't part of the standard of 1.2, they were added on later, are now incorporated into the base RFC for 1.3. And a few new curve algorithms like ED25519 and 448 have been added, which weren't defined under 1.2. Version negotiation has changed in TLS, largely because of backwards compatibility issues. If everyone had followed the RFCs correctly and implementing 1.0, 1.1, 1.2, this wouldn't have been a problem. Unfortunately, people can't follow RFCs. There are lots of broken implementations out there. So the problem was, if you tried to use a standard thing and you sent, okay, I wanted, like in TLS 1.2 and earlier, you have your protocol version in the client hello, and you say, OX0303 is TLS 1.2, and that's defined in there. So TLS 1.3 would be 0304. But if you do that, lots of things die. They don't know what you're talking about. By RFC, you're supposed to look at any value you don't recognize and ignore it, and basically come back with, I don't know what you're talking about, but here's my best value. Because of this, they introduced a new method for negotiating version in TLS1.3. And what they've done now is a TLS1.3 handshake looks like a 1.2 handshake unless you understand 1.3. So it kind of falls back to 1.2 because a system that doesn't understand 1.3 will ignore this new extension and it will think it's talking as like the client's coming in 1.2. And also they've introduced the ability to negotiate for DHE, for what's officially finite field Diffie-Hellman ephemeral, the ability to negotiate key sizes. Because that's been an issue, you can have Diffie-Hellman ephemeral could have 1024, 2048, 4096, but there was no way for the client and server to negotiate with each other on what those key sizes would be. The TLS1.3 changes the way cipher suites are defined. As I said, all the TLS1.2 cipher suites are gone. They all are AAD now, and the hash algorithm is all what's called an HMAC-based extract and expand key derivation function, which I won't get into, but there's an RFC for that. Key exchange and authentication are now handled separately and are not defined in the cipher suite. So you can have, instead of having to explicitly define every possible combination, you can set up, these are the key exchanges I want, these are the authentication algorithms I want, these are the cipher suites I want, and the system can mix and match those to a little from each column. So for TLS1.3, say the equivalent of a TLS1.2 algorithm would be the ECDHE, RSA, AES226, that long string, that's defining everything. For TLS1.3, you just say TLS, AES, 256, GCM, SHA-384. You notice the ECDHE, RSA are gone because those are configured separately. Those aren't part of the cipher suite anymore. So you can't use TLS1.3 defined cipher suites and 1.2 and earlier and vice versa. There's an incompatible line between the two. On Big IP, all of the TLS1.3 cipher suites start off with TLS1.3, or it's like 13. So you can see them clearly when you're listing ciphers that those are TLS1.3 and above. So the cipher suite format, excuse me, in 1.2, this is how it will be defined. You have your key exchange and authentication algorithms, the symmetric algorithm that's used for encryption, and then your MAC is defined on the end. In TLS1.3, since only DHE and ECDHE are supported, the key exchange is gone. And there's a separate configuration for that now. And so on Big IP, as I said, it'll be TLS1.3, and there's now Diffie-Hellman groups to define your key exchange and things on Big IP. So starting in 14, as I said, we have kind of preliminary draft 26 support for TLS1.3, so that if you start looking at client ciphers, or it's only actually, that's something I'll talk about, it's only on the client side right now. If you just list the TLS1.3, you'll see that we currently support 2 ciphers under TLS1.3, because the list for TLS in total is much smaller. So if you're looking at it, when you're looking at all the ciphers, they come up at the end of the list right now. And you'll see there's currently a question mark for the key exchange. And as I said, that's because key exchange is defined independently of the cipher suite. We have 2 new configuration options, supported groups and key share. Supported groups defines the key exchange algorithm, and there's only 2 options right now, is ECDHE or DHE. Key share defines the cryptographic parameters associated with that. So if you say you choose ECDHE as a supported key, you can specify things like your curves in the supported groups. TLS1.3 also supports PSK, and PSKs have to be shared out of band. But note, Big IP doesn't support them. I'm just kind of talking about the protocol there. There's not really a use case for Big IP to use pre-shared keys. So we have our cipher rules set up. When you're configuring things now, you can see we have the new, this is like a client SSL profile. You now have DH group and signature algorithms as well. You can see it on the command line. And you can see your new cipher suite set up. So that's the 2 ciphers are configured here. So when you're setting things up now, under 1 or 14.0 and forward, you'll see options to configure things for TLS1.3 if you've configured it. The supported groups extension was previously named elliptic curves. It was just named elliptic curve groups, but once they added the ability to negotiate finite field, it was just kind of renamed to supported groups. It's also where you can list your finite field Diffie-Hellman key size groups that you want. Like I said, 1024, 2048, that kind of thing. You used to be able to put in custom elliptic curves. That's no longer supported in TLS1.3. It's really only meant to be supported from the client to the server. Basically, it's this client saying, this is what I support. It's like you used to do with Cypher suites. You send them in. The server can send it to the client, but it's basically just there as a reserved for future use. Like right now, any client implementations are supposed to just ignore it if the server sends it. But it's there for possible future use. On big IP, as we saw on the last slide, we call this DH groups. And we don't, in 14.0, we don't yet have support for finite field Diffie-Hellman group negotiation. That is on the roadmap for future release. And you can see the available Diffie-Hellman groups on the box by looking at the audit field for the F5 default cipher group, or in the help it shows you. The new key share extension was part of TLS1.3. Clients will, as they're negotiating, if they want to negotiate TLS1.3 with the server, they pre-generate a key and place it in the key share extension that they send into the server. Clients can generate basically as many keys as they want, but the keys are designed to match whatever they send in the supported groups field. They're supposed to generate keys for every item they put in that field. If the server decides to pick one of the ciphers that the client sent, and this client for some reason didn't send the key share item to match it, the server basically sends a server retry request back to the client saying, hey, I want to use this, but you didn't tell me what keys here to use, so let's try again. And that's basically just, if you're wondering why you see that, just kind of make sure that the client was sending that in. There's also now a signature algorithm extension for TLS1.3. It allows you to specify signatures allowed for certificates. There's a signature algorithm cert extension. It's using the certificate verify message that comes back. It's optional. If you don't specify that, it just falls back to the signature algorithm. There's a new signature support scheme for TLS1.3 called PSS, probabilistic signature scheme. That's required for support in TLS1.3. The client doesn't have to use it, but you have to support it if you want to be RFC compliant. So this is like kind of a list of what the RFC now allows for key exchange. Like I said, you have Diffie-Hellman ephemeral, you have elliptic curve Diffie-Hellman ephemeral. Over here, key exchange, the auth algorithms. These are what's all allowed, and then the ciphers. The ones here in yellow are what we are currently supporting. So we support 3 different options for ECDHE. We still support the RSA auth, a couple different options, 6 of them. We support ECDSA, and then we support AES-GCM. We have this cha-cha coming in a future version, and we're looking at adding DHE finite field in the future version. This is how it looks on a big IP from the previous slide. These are the options that are available, and you can see what the RFC calls them and what they're called on a big IP. All right, so these are the handshakes. Kind of going back to TLS 1.2. Back up. So in TLS 1.2, you have your client hello, server hello comes back with its server certificate, the server key exchange, server hello done. The client comes back with its client key exchange, and then if they've agreed at that point on their their key and the algorithms being used. They say, change cipher spec, which basically says the client at that point says, from now on, we'll be talking encrypted. The server responds with its client change cipher spec saying, great, we'll talk encrypted, I'm done. And then from then on, you have your encrypted data. So you basically have 2 round trips. It's 2 RTTs, you say coming in, back, and then client finished and immediately starts sending data. In TLS1.3, it's one round trip, which doesn't seem like a lot, but if you're handling a lot of high volume things, that's one less packet exchange for every connection. So now the client sends all of its things in its client hello, it sends everything it needs in the first packet coming in, the first frame. The server responds with everything it needs, and as long as everything's good at that point, the client says, client finished, and here's my data. It can send it right in one packet coming in. And then we're back, we're talking encrypted already. So that speeds up the handshake for TLS1.3, and that's a major change. If it doesn't work out as cleanly as you hope, the client comes in, the server can say, try that again. Maybe the client comes in and I want to support these ciphers, and the server goes, I don't do any of those. Here's, try that again, here's something else. And the client might come back and say, okay, how about this instead? So you can fall back to a 2 exchange, but that's kind of going to be unusual. The hello retry request is a new message type in TLS1.3. The problem is there are lots of middle boxes out there. You think big IP, although we don't have this problem, but there are a number of proxy devices and things out there which do protocol inspection and look at the protocol coming through. And if you introduce a new message type, a proxy would have to be aware of that new message type, or it would just think it was bad traffic. Like I don't recognize this packet. What is this, hello retry request? I don't know what hello retry requests are. So in TLS1.3, even though it's a new message, it looks identical as the old server hello. But what they've done is the random value that's normally in the server hello message is this string, which is just the SHA-256 hash of hello retry request. They've done this a lot in TLS1.3, where they've made things backwards compatible by pretending to be a TLS1.2 message and then sticking some special key value in a given field. And this came about during all the development of TLS1.3 because they kept trying to do things the way you'd want to do it by, hey, we're going to issue a new message. And as soon as they put it in the real world and tested it, it broke because all these middle boxes broke. Okay, well, we can't get the whole internet to change 10 years worth of history. So how do we jury-rig this to work with what's already in the field? And this is how it works. So that's one thing debugging, if you're ever troubleshooting this stuff, it gets interesting because if you just like Wireshark, newer versions of Wireshark are TLS1.3 aware, but older ones would see this as would think this was a server hello TLS1.2 message. You can also make connections. TLS1.3 has support for what they call cookies, to cookie a connection. It's an extension, so you can, just showing all different types of handshake possibilities in 1.3. A lot of these you won't see on Big IP yet, like I said. So this is kind of a closer look at how certificate messages look inside TLS1.3. All these things are extensions in the client hello. And the server responds, and it can send all these messages, sends its requests. If you want to do this, this is for obviously client certificate authentication. Like you probably can see that in like a corporate environment where you might give each employee a digital certificate on a smart card or that kind of thing. So they send a certificate request, it sends its own certificate, it sends certificate verify message, and it's finished, and it can start sending application data. And then the client responds with its messages. And then you're talking encrypted. So it's again, basically one RTT. The thing is that's gonna mess you up when you're trying to troubleshoot TLS1.3. If you've ever debugged TLS, if you've ever done captures and looked at TLS, 1.2 and earlier, all the handshaking is in the clear. Not so in TLS1.3. All those green fields are encrypted in TLS1.3. So you can see very little in the handshake without decrypting it. Whereas there used to be, you'd have to dump one key out, say on big IP to decrypt TLS1.2. There are 4 keys for every TLS1.3 connection. There are a client key and a server key for the handshake, and then a client key and a server key for the application data. And you need all 4 of them to decrypt everything. I'll talk about that too. And you can send change cipher spec from the client back. It's a dummy message. It doesn't do anything in TLS1.3, but again, there are middle boxes out there which break if they don't see it, because change cipher spec was always there for TLS1.2 and earlier. And so some middle boxes might go, oh, this connection isn't fully established yet. I didn't see a change cipher spec message, so I'm not gonna let anything continue until I see that. So clients sometimes can just send that, like, yeah, sure, change cipher spec, and the middle boxes go, great, you're done. And basically it's just a dummy message, doesn't mean anything. It's just there to satisfy state inspection. You can also do session resumption in TLS1.3. Basically you store a key from the previous session, you can reuse the key to start a new session. And we don't do this yet. Like I said, initial support, 14.0, more are coming. The other big change that I mentioned for TLS1.3 is this idea of 0 RTT, where you have 0 round trip time to start sending encrypted data. You basically use this as a new extension that you can put in the handshake called early encrypted data or early data. Basically the client, if you had a previous connection with the server or in the pre-shared key kind of environment, you can basically use that last key, use it to encrypt the data you want to start sending, send it in your new handshake, and if the server still knows what you're talking about, it still knows what key to use, or if you had a pre-shared key environment, it can read that message in that first packet while you're negotiating a new key to use for the remainder of the connection. There is lots of debate over this because there's discussion about replay attacks because you were using a key in that first message. There are some mitigations for that. Okay, I said that. So the first packet, because you're using that key for one packet only, it's possible to replay against that packet. It's still a one round trip. It's basically a one round trip or one RTT handshake with data attached to it. And then from that point on, it's just like a connection with one RTT. Everything down here would be with a new key. So it only, like I said, it only works if you're using pre-shared keys because both ends have to have the key, or resumption because you have a key that you saved from a previous connection. Obviously, chicken and an egg, you couldn't start talking to someone you never talked to before and have a key because you wouldn't know a key, right? Don't do that yet, but that is future. And you can also do the 0 RTT with cipher negotiation. It just adds another hop in the middle there. And it's basically, you can start seeing these are all permutations of each other. Again, we don't do early data yet. This is a radical new concept. I mean, it's nothing, 0 RTT is a new concept in general to TLS. We want to get the stuff that's always been there working in TLS1.3 before we start adding too many radical things. And there's not a lot of widespread support. And especially, again, because this only works for pre-shared key, which we're not going to be supporting, or session resumption, it's a very limited use case. So not a lot of need for it. As I said a few times in there, for compatibility with middle boxes, yep.
Just going back a little bit on the negotiation, when it fails, because the certificate would be valid or something like that, is there a way for you to see that error, or that's encrypted so you cannot see it?
Kind of just like in TLS1.2, if you get you have the error messages in 1.2 were encrypted. It's all encrypted.
So follow from that, so you're doing early data first, and if it does fail, what happens to that data?
It's thrown away. It falls back to a standard handshake. So if you want to say, if you're a client and you go, I want to do 0 RTT and here's some application data with my first packet, and the server goes, I don't have that key anymore or whatever, the server just comes back and says, nope, it basically when it sends it back, it goes, I'm not doing early data with you. And the client starts over. But it doesn't have the key to decrypt it.
The data's encrypted and you can't read it, so just discard it and find out.
Yeah.
So it keeps that data in a buffer to send when it actually does in the
Yeah, the client would have to resend that again, and then when it starts, because basically the server, if you try to do 0 RTT and the server says no, for any reason, the server has thrown that packet on the floor, it's thrown that data away. So you have to do a regular handshake at that point, start a new connection, and then you'd have to start over again sending the data. So the client would need to remember, hey, and any implementation should do this. The client should be like, oh, the server, I sent it to the server already, but the server rejected it, so I have to send it again with a new key. Well, it's not a retransmit, it's like a whole new frame. It's retransmitting the same data, but it's all encrypted from scratch again because of a new key. So as I said, there were a number of things that were done in TLS1.3 because people can't follow the RFCs. Like the older RFCs, if you didn't have broken implementations and broken middle boxes, this wouldn't have been an issue. So there's a number of things that are in the RFC that basically say, if you really want your implementation to work, you should do these things. Like session ID is sent in the handshake. It doesn't mean anything in TLS 1.3. But again, lots of middle boxes look for that, and if it's not there, they say this is a broken connection, I'm not going to allow this. So you put a dummy value in there. The change cipher spec, most implementations are sending a change cipher spec, even though it doesn't do anything in TLS 1.3 because of middle boxes. The compatibility is basically something called compatibility mode in TLS 1.3, and if the client sends session ID in its packet, the server implementation is supposed to, we're doing compatibility mode, okay, so we're trying to get around some broken middle boxes. So the server is supposed to do these things. It's supposed to send the session ID back, even though neither end cares about it, the middle boxes probably do. It's supposed to send the dummy change cipher spec message at the end of the handshake, again, even though it means nothing. If the client doesn't send a session ID, the server can send that stuff, but it doesn't have to. And what some implementations will do is a client could try to do a handshake without sending that stuff. And if the handshake fails, it might try again and send it, because it might go, oh, it didn't work. Maybe there's something between me and the server messing with me. So I'll try compatibility mode. Other implementations will just always do compatibility mode just because the state of the internet is so broken. In 14.0, again, early implementation, draft 26, we don't retain this. That should be in there, I believe, in the next release. So by the time we have official support, we'll be RFC compliant. So a lot of handshake messages that used to be there are gone now. So when you're debugging, there was a server hello done. Now it's just an extension in that server message that says finished. The client hello done, again, it's just a finished extension now. Change cipher spec, it's gone completely, it's just there for fooling middle boxes. The client key exchange and the server key exchange messages are gone. There's now a new extension called key share. So a lot has changed in the handshakes. Again, this is why I think 1.3 is kind of a deceptive version number. I talked about that hidden message, the encoded message earlier. Hello retry request, looks exactly like a server hello in TLS 1.2, but it has a completely different purpose. It's identified by this special string, which is just a SHA-256 of hello retry request in the random field. So actually, obviously it's not random. Again, middle boxes. Middle boxes hurt a lot. There's also, the server hello has a random field. And if the client comes in and it's a TLS 1.2 client talking to a server that does 1.3, the last 8 bytes of the random field, according to the RFC, must be set to that specific value. So it's random except the last 8 bytes. And if it's a 1.3 server negotiating with a 1.1 or late or earlier client, it sets it to a slightly different value. This last byte's different. And this is basically a way of the server signaling. Imagine if there's a man in the middle trying to do a forced downgrade attack. And so a TLS 1.3 client is talking to a 1.3 server, but something in the middle is going, I'm gonna make you talk 1.1 or 1.2 so I can use attacks that I know against you. By sending this random value back, the client could look at that and go, wait a minute, the server does 1.3 and I do 1.3, why are we negotiating 1.2 or 1.1? And it could probably abandon the connection at that point. It's supposed to. 14.0, this obviously doesn't work that way. We will have that in there in 14.1. It's in the code now.
So 1.0, it will never be a successful handshake.
What was that?
If either side sees a 1.0, it would never be.
If both sides actually support TLS 1.3, because a 1.2 client wouldn't know that's a special value. It would just think it's a random number. So basically, it's a way for, there's a way to basically signal there's something in the middle messing with the protocol. Because if a client only really is a 1.2 client, it would be, oh, that's great, it's a random value. I don't know that's special. But a 1.3 client would go, wait a minute, those last 8 bytes are special. Right, if a client receives, if the random field ends in either of those two strings, the client, according to the RFC, must reject the connection. We'll have that in there by 14.1. I honestly don't know exactly why the history. I have to go back and look through the mailing list and see why they picked a different value. But yeah, because only a 1.3 client's going to recognize either of those. Yeah, I mean, I suppose you could do this. New implementation, or somebody who's still writing implementations of 1.2 could now look for these special values and would recognize that it's a 1.3 server, and and so it's a possible signaling value that way. But any existing implementations aren't going to know what these mean.
So is this one of the ways for you to find out like who is still like what percentage of your clients are still using 1.2 or 1.1?
Well, you wouldn't need to look at this because you could just look at the stats on the VIP saying what protocols got used. This is really only to prevent man-in-the-middle attacks against a 1.3 client.
But you can do like a SSL debug and you throw the logs in the same as IP address that return this value so you can get a list of IP addresses.
Yeah, you could. You could see if you wanted to break it down. I mean, yeah, you could see what values were set, although I believe that extension is encrypted in the handshake, so you might have trouble dumping it out. You have to decrypt it. Oh, no, wait, the random value, no, I think the random value is one of the ones that isn't encrypted, so you can probably dump it out. And then the connection would break because the random value is used to calculate things. And so if the two ends didn't use the same randoms, the connection would fail further down the handshake. So as I said, there's a lot of issues here that can cause issues with supportability. How are we doing on time? Right now, we only support this on the client side for client SSL. It's not supported yet for server SSL. That is coming. Probably 14.1, I believe. In client SSL, it's disabled by default in 14.0. Again, we only have draft support, so we kind of have it off because we only want people who want to test and play with the draft to turn it on. I don't know if it'll be on by default in 14.1, but like official RFC support will be in there. Do you have a question? Yeah, I actually I think I have a chart later on that shows compatibility metrics. There are, like Chrome there's a couple different browsers out there that have implementations. The problem is you need something that has specific draft 26 support to work with 14.0. There's a few clients you can use it with. If you try to enable this on the server SSL side, you basically get this warning, hey, don't do that yet, it doesn't work. So you can enable it in the client SSL profile, under advanced, by default, it has the no TLS1.3 now. It's a new option. You just remove that. And then you'll have TLS1.3 turned on. Oh, there we go. So we have draft 26, and this is the confusing thing. We only know this graph when it was about 18. So Wireshark actually can debug all of these. So we have a server here, OpenSSL, so like S-Client can talk to us, a couple of other GNU TLS, so there's a couple things that can talk to our draft support. And draft 28 is now the RFC, and we will have that support in 14.1. And you'll see a lot more things, like a lot of these empty boxes will start having, will have X's because now it's a final RFC.
Silly question from the last slide. When I upgrade all of my devices to 14.0, it's going to put that option in.
Yeah.
Put all of my pre-existing client profiles.
Yeah, it's in there by default.
Oh, they did.
Yeah, pretty much whenever we introduce like a new major protocol revision, like we generally don't throw that switch on by default. We know that breaks things. So there's limitations of 14.0. Like I said, it's draft 26 support. It's basically there for preliminary testing. It's a timing thing. 14.1 will be out soon enough. And like I said, it's just got Friday, like literally was when the RFC was published. So there's not a lot of use out there yet. Not gonna see that for quite a while. So things that are coming, no session, we don't do session resumption yet. That's coming. Client cert authentication, which is used primarily again for like a corporate environment. That's not supported in the TLS1.3. In fact, today, even if you in 14.0, if you enable TLS1.3, but you also enable client cert auth, the VIP will be forced back to 1.2. 1.3 will not be turned on because it doesn't work under 1.3 yet. That's an upcoming release. The finite field Diffie-Hellman support, that's coming. Cha-Cha 20, this new cipher, that support is coming, I think 14.1. Zero RTT is not 14.1, it's on the roadmap, but that's a major new kind of thing to deal with. It's not easy. I put this note in here. I would say you do not want to use 14.0 TLS1.3 in a production environment. Because again, it's draft 26 support. You saw that matrix of clients that use. It's really there for testing and for people getting familiarized with things before you go, if you want to get prepped for 14.1 and final RFC support. So we have some trouble here though. Anybody who's done SSL dump or dumped pre-shared, pre-master secrets out to use in Wireshark and all those things, none of that works anymore in TLS1.3. SSL dump completely fails with TLS1.3. Dumping out pre-mastered secrets means nothing in TLS1.3. Everything's ephemeral. Everything, RSA is gone. So that causes a problem. It also causes a problem for proxy SSL. So none of that works in TLS1.3. If you enable TLS1.3, if you need to use it, proxy SSL is dead. It will never work again. It only works in pass-through mode. There is no possible way to do proxy SSL with TLS1.3. So forget it. That's a harsh message, but that's just how it is. For decrypting SSL traffic, we have a guideline out there, K16700. There's an SSL, an iRule, you can do SSL session secret. That doesn't work in 1.3 either, because that's totally changed. As I said, it used to be one key, which that would dump. There are now 4 keys. I'll be getting to why, this is what broke. I'll be talking about how we fixed it. So like I said, all of the handshake messages after the initial server hello and some of the fields, all of those extensions are encrypted with those handshake keys. That makes troubleshooting much harder, in my more opinion, because you can't just look. And a lot of times you're debugging TLS, you don't even have to decrypt it. You just look at the handshake. Oh, the handshake failed here. Well, it's not always that easy anymore. A lot of the old things that used to be in the clear are now moved into encrypted extensions. So the PCAPs are almost useless unless you start decrypting them, which makes troubleshooting more fun. So there's an iRule now, or several iRule things. Basically, there are 4 keys. So you can attach this iRule to your VIP when you're doing troubleshooting. And if the cipher version is TLS1.3, You have your client handshake secret, your server handshake secret, then your traffic secret, and your server traffic secret. So those are the 4 keys. And you can also use the same I rule if a different protocol, like this will dump the old key out. If that same BIP falls back to TLS1.2 or earlier with the client, that will work for the old keys. So that I rule will work for any version of TLS that's supported now. 14.0 got released last week. I don't know if anyone's pushed to have that solution updated yet. I've been out of the office since before it released, so when I get back, if they haven't, I'll probably push to have that fixed, or at least add this I rule to the solution. It wasn't up there before, obviously, because it's chicken and egg. They want to publish this until 14.0 was out. But I usually check on these things, and I was at Black Hat and DEF CON last week. And also the other issue though with this I rule though is this really only triggers once the handshake finishes, and then it dumps all the keys out. So if the handshake fails for some reason, nothing gets dumped, and there's no way around that currently.
So with older versions of SSL TLS, if you have Wireshark, there was an extension where you could basically put in a copy of the certificate in private key.
Mm-hmm.
Assuming you have the certain key, is that still possible?
No. All TLS...
Even if you have the entire packet capture?
Right. TLS1.3 is ephemeral. It's all Diffie-Hellman ephemeral or elliptic curve Diffie-Hellman ephemeral. That method you're talking about only worked with static key exchange. It didn't work for ephemeral keys under TLS1.2 and earlier. And with TLS1.2 and earlier, you could dump out what they called the pre-master secret, which is what that is there. But that doesn't exist anymore in 1.3. Now it's 4 separate secrets. So yeah, you can pull these into Wireshark. Like this, when you dump all 4 of these keys, a version of Wireshark that understands TLS1.3 can also ingest all 4 of these keys and use them.
But you have to get forethought to the log.
You have, yeah. You can't after the fact go back and recover. It's just like that. The same problem existed in 1.2 and earlier if you were using Diffie-Hellman ephemeral or elliptic curve Diffie-Hellman ephemeral, because it's the ephemeral key is per connection. So there's no way to regenerate it after the fact. So in TLS1.3, everything is ephemeral, so there is no way to generate anything after the fact. But yeah, that security is always a trade-off with convenience, right? Yeah. Yeah, you need both sides.
With these, you can actually get the key without having the second side. So you can encrypt without needing to ask the server to 17 to give you the private key. So actually, these I will also better than the OpenSSL or the SSL that we use.
Yeah, we'll get more. There are some benefits, I guess you could say. But you have to have you have to be deliberately debugging. It's not like you can go, oh, that connection failed. Now after the fact, I want to go look at it. You can't go and get the keys after the fact. You have to plan ahead. There's another way to get the same secrets. Like this was how you do it on the big IP. You can do it from the client side, same way. Like you just said, like we're the client, the server side connection. Most browsers, at least Chrome, Firefox, I believe this works on IE, and it works on all 3 platforms for those 2 browsers. If you set a file, you set the environment variable sskey log file, you give that environment variable a path to where you want the file to live. When you start the browsers, they will start logging out those keys. And that file that gets dumped, you can pull it into Wireshark just like a pre-mastered secret file that you can use today. So there's 2 ways to get the keys on the big IP or on the client side. And this is the file format that everybody uses. Well, you got to figure the client, there's always, yeah, if somebody compromised your desktop box, but those keys always existed in memory anyway. So if your desktop box is compromised, I could always, if I compromised your box, I could always dump those keys. I could just pull them out of memory. Yeah, so if someone can get on your box and set that environment variable, there were other ways they could have gotten the keys already. So like this is kind of the matrix of what we're talking about. TLS1.2 and earlier, SSL dump only worked when you weren't doing ephemeral things. It didn't work for the ephemeral keys, and it didn't work at all in TLS1.3. TCP dump, when you dump the keys using iRules, that would work for ephemeral or not ephemeral TLS1.2, but doesn't work on 1.3. The new iRules only work on 1.3, which is why that iRule I showed you has both options in it. It does both of these, depending on keys off the version. So it covers all three. Or if you dump it from the client side, that works for everything.
Is the clone pool still available? So I can dump decrypted logs to a log server through the clone pool?
Yeah, that's still available because that exists outside of the encrypted connections because you terminated the encrypted connection coming in and then you clone that decrypted data out.
Yeah.
So that's independent of TLS.
Okay. It's not
No. So this is the new help that's on the box. I don't talk about all this, but this, if you look at the Cypher rule help now, there's all this new content in here that talks about TLS1.3. So you've got your DH groups, and it shows these are curves you can specify, and those are the 3 curves that are currently available. Default will work in there. Your signature algorithms, and these are all the available signature algorithms that are currently supported. And again, there's a default. For people who are looking at this now, as I said, the final version number for TLS1.3 is they're going to be 0304, but the drafts all used, because it had to iterate a lot, and to be able to differentiate the drafts, use a different thing. So right now, this is what you'll see on our box, because we do draft 26, so the version number will be that in 14.0. By 14.1, it'll be 0304. Well, I don't want to get into too many details about debugging it. It looks a little different. Do you want to do the roadmap?
Alrighty. Can you hear me? We live? Okay, good. So some of this has been touched on, but I'll go into a little bit more detail. First, the product manager. I'm actually responsible for our SSL. I'm responsible for our certifications, global privacy, so that includes hardware security modules. So if you're a regulated industry, guess what? Hardware security modules need to deal with TLS1.3. The PSS padding is a requirement. So if you have any roadmap questions, as well as our SSL orchestrator, so our actual product that does do that man-in-the-middle decrypt is all part of what I track and work on. And obviously that all sort of ties together. But so I think we sort of talked about this, right, today, or we have been. We're always trying to be ahead of the curve, especially because we are full proxy. We need to have the best, the latest recommended Cypher supported on both sides of that communication. We have been TLS 1.3 tolerant for a while. The F5 Cypher builder, anyone in here have used that sort of versus the old way where you have to go in and modify your default string and you get it wrong? And that really came up as part of the whole Snowden, when people wanted to go to forward secrecy. So that should be making everyone's life a lot easier to make sure you don't have a null string or a bad string. And then the dynamic CA bundle update, more so on the SSL orchestrator side, where it's really important because you have to have the latest update so that you don't break on those connections. But it is also relevant for just the reverse proxy. SSL visibility, as we talked about, so that's the SSL orchestrator. So the comment, right? So proxy, how many people in here have heard of proxy SSL or SSL, split SSL sometimes referred to? Very large deployments in a lot of our government where you have sort of a source destination IP requirement that has to be maintained. There's no perceived, or the expectation is there's not a proxy in the middle. That breaks, as he was saying, right? With the ephemeral, the TLS 1.3 stuff, it breaks. So C3D is actually our answer to that, and it's coming in 2 phases. The first phase was delivered in 13.1. And again, if you're using CAC PIV cards, Connecting to Exchange, for example, that's really a requirement now as we go to, and it first was driven from forward secrecy, but obviously with TLS 1.3 now favoring that and mandating that, you really need to talk to us about C3D. So if you are using the proxy SSL, that's the way to address that.
This one, the hibernation, the battery.
Oh, yeah. Yeah. And I know we're coming up here on the time, but as was mentioned, so 14.1 will support the RFC. It was, as of a few weeks ago, based on 28, but that will change as we go into 14.1. 14.1 is our end of year release. And then I should say, though, in 14.0, even though it's based on draft 26, the curve 25519 is in there and is supported. So if you want to start using that, it's actually not directly tied to the TLS 1.3. So, and if you're not familiar, globally we get a lot of requests for that curve because it's not Suite B, it's not NSA. There's a perception that it's a little bit more, well, let me say it's a bit more trusted. It's actually more performant. So that is in the release that just came out. 14.1, again, that's the end of year. Will be based on the 8446, and then Cha-Cha Poly is coming in that release. And then the 15.0, so that would be roughly this time next year. This is our list of things. DH2K, so we support 1K today. We've gotten a lot of requests for 2K. The TLS 1.3 changes actually makes more sense. So that was a good time to add that. The 0 RTT, we talked about the big concern there, and that's why we're going to make sure we get it right, is that there's the replay. You get better performance, but there's the replay concern. And actually at Black Hat, there was a great session by the Cisco guys. Most of the remediation for that replay is actually done on the application. Well, good news, right? F5, because we're acting as a full proxy, we can actually do that on the big IP, so you don't have to modify your application, but still have that replay protection. So that's actually a differentiator for us, and we'll have a nice write-up on that in the documentation. Also, TLS 1.3 for our SSL orchestrator. Obviously, it always comes client-side, server-side. We have to get into the big IP formally, and then we'll actually make sure that it's available in our visibility product today. But again, back to actually the next one. Just okay, like you'd already seen here. And actually 24 was where it broke those middle proxies, right? Those man-in-the-middle products, because they're half proxies, they actually weren't able to negotiate like 25519. 26 is where they fixed it, and like I said, that's the draft, but this is the one that we're targeting for the next release. Yeah.
Today it does not. Microsoft certainly will. They just haven't. They
Yeah.
haven't yet. I mean, what's Microsoft show? Where are they on there? Microsoft. Yeah, they supported back in 21, draft 21. They haven't updated the support since draft 21.
Yeah, just.
Oh, it's from Microsoft.
Yeah. Well, and this is one of the reasons we historically, F5 historically hasn't built code based on drafts, because you never know, right? But the other reason I wanted to just show this again was just if you have products, right, is you need to check with your vendor. This comes up for our SSL orchestrator because we support all these security services. A lot of those security services aren't all at the same point. Not everybody's here, right? So you want to make sure that you're talking to your vendors on these products and making sure that where are they at, right? So that's sort of the key takeaway. But again, 28, we are going to support the. And then again, this is the C3D that I mentioned. So this is the replacement. We actually have a patent on this for what had been the proxy SSL or split SSL. Phase 1 is the local delegate, and then Phase 2 is the remote delegate. And if you're interested in this technology, certainly give me a shout or contact me, and we can get you some more details and demonstrate that. But again, very much, in probably the biggest use case is when you have an application that is not proxy aware and or has a client certificate. CAC-PIV cards are, again, the perfect example where we see this often deployed. So, and I think that's it. I think we're right up at time.
Thank you.
Regarding the client cert, is that going to be available with 14.1?
Client cert auth, I think it's 14.1.
14.1.
Yeah, 14.1.